Hello everyone, this is Singh Shekhawat and today we will be deep diving into chapter 6 of designing data intensive application which is partitioning. Partitioning पे हम discuss करने वाले हैं what it means, what are different techniques of partitioning and how you can achieve it, why you actually need it, क्यों करना ही है हमें partitioning. We will be discussing all those things in deep details. So let's start into it. First of all, what is partitioning? So we have to first deep dive into कि partitioning है क्या, ठीक है. So when we say partitioning, it's basically breaking your data into multiple parts. Okay, let's say this is your big database, this one is your big database, and right now what you are doing, you are breaking this database into multiple parts. Let's say p1, p2, p3. So you broke your database into three parts, and if you combine this database, if you combine these parts, you will get the same database back. ठीक है, समझ में आ रही है बात. So if you look at a partitioning, it's from outer world, it's same, it's exactly same. ठीक है, you are storing the same data as you had earlier, but it is logically separated, it is physically separated and stored into multiple places, it's stored into multiple parts. That's we called partitioning. Now why actually we want to do it? ठीक है, if we want to do anything, there must be some reason associated to it. ठीक है, let's say I am storing some data, why would I want to partitioning it? मेरा काम सबसे बढ़िया एकदम सही चल रहा है, क्यों करना है मेरे को, है ना? Like anything we do, we should have a good reason for it. Otherwise, we are not spending our bandwidth, we are not spending our money on it. There is no point doing it. So why is actually partitioning done? So it's basically to scale your system. To scale your system, scalability is your main parameter for, and which is the reason why partitioning is done. So after certain point, data can't fit into single machine. Same like you can directly compare it to vertical scaling and horizontal scaling. When we say, when we try to manage load on our systems, we first try to vertically scale it. ठीक है कि this is the amount of TPS, this is the amount of users my system can support, but after a certain time you would have to add more machines to support the TPS, क्योंकि एक टाइम के बाद में अपने पास that amount of CPU or memory will not be available with us. ठीक है, तो सेम गोज हियर. आफ्टर अ सर्टेन पॉइंट वी विल हिट ए थ्रेशोल्ड. ठीक है, वी विल हिट ए थ्रेशोल्ड कि डेटाबेस इससे बड़ा नहीं हो सकता, इतना बड़ा अगर हमें चाहिए, वी विल नॉट हैव दैट डेटाबेस. So to solve that problem, to solve the scalability problem here, we use partitioning. We divide the data into multiple parts. The partition data should also be replicated on multiple nodes. For last chapter we discussed around replication. So the data you are partitioning, it should not be, it should also be replicated among multiple nodes, right? Because we want to be fault tolerant, we want to be highly available. ऐसा नहीं होना चाहिए कि like I have scaled my system enough but right now I am not able to serve my requests. So we have to think in all the parameters, all the parameters, so that our system is available for our users. Whatever we are promising, whatever my system is supposed to do, it is doing that 100% availability, minimum latency के साथ. Now certain techniques we will be deep diving into it. First one is partitioning of key value data. So let's say you have a key value data, key, and then you have a value. If you have this kind of data, so let's try to partition this data. Okay, so what we're trying to do is, idea is to make sure data is evenly distributed among all nodes. Okay, so let's say you are partitioning this data into multiple nodes here. Let's say this one use big database, and then you try to partitioning into three parts, p1, p2, p3. Now we have to ensure that data among this partition is equal. We don't want ki on a single node the load is increased too much and on the other nodes there is no load. If we are dividing data, we have to ensure that all nodes have evenly distributed data, so that they can take that same amount of load, and any other part, like any of the parts, any of the partitions which you created is not overloaded with anything, with data or with the TPS you are hitting with to extract the data actually. समझे बात? So what we are trying to do, we are trying to evenly distribute the data on all the nodes. If data is unevenly distributed, it's basically we call it skewed database. कि let's say these your three parts, p1, p2, p3. p1 this is your p2, this is p3, and on this particular node the data is too much. ठीक है, this data is too much. it's overloaded. यहाँ पे you don't have too much data, यहाँ पे you only have single entry. So in this, we don't want to have this kind of scenario. If we have this kind of scenario, we called it skewed. Now, the first approach would be partitioning by key range. So the keys which you created, can we do something like we divide these keys into parts? Let's say this example, right? You have the keys from A to Z. It's a simple example. Your keys will not be like A to Z, but you can like right now assume that you have keys which starts from A to Z. Now what you are doing, you have divided this data in three parts: P1, P2, P3, and in these parts you have, in first part you have data from A to E, then F to P, then Q to Z. ठीक है, depending on that you did some basic analysis, you analyze that the entry starting with A could be more, so in first partition you only kept entries till 5, ठीक है, only 5 keys you kept, then you in this part the entries are more, ठीक है. So that we can decide basis our analysis, that can be basis the use case. ऐसा नहीं होगा कि मतलब A to Z है तो you divide 26/3 ना, समझ रहे हो. So we are not doing that sort of thing here. It could be basis use case to use case, that this is the traffic, or like this is the data which we expect for these keys maximum. Then you can divide, or like you can create those partitioning based on those keys accordingly, basis your analysis which you have done for your use case. Now what we are doing is that we assign the unique continuous range of keys to each partition. Now within each partition, keys are sorted, and this can be done by SS table and LSM tree. We already discussed it in our earlier chapters, okay, where we discussed around how databases work in the backend actually, okay. So in that chapter we discussed around SS table and LSM tree. So we are doing that same here. Okay, it is used in backend. So what we are trying to do is we are trying to maintain our keys in a sorted order. And here, since we are maintaining the data per ranges of the keys, the range query will be pretty simple. Okay, let's say I want data between F and Z. Then I know I have to go to this database and I can query the data, and keys are already sorted. So it's pretty simple here. Then there can be also downside, फायदे तो नुकसान भी हो सकते हैं, समझ रहे हो बात. तो there could be some access patterns that can cause hotspot. When we say hotspot, what we mean by hotspot is this is the hotspot here, when the data is overloaded on the single node. So that single node is getting too much TPS of write and read, and these have very less TPS to serve with. So this node here, this P1 node here, is your hotspot. If a single node is serving too much TPS, if a single node is bombarded with the requests, so in that node will be called your hotspot. So we have to avoid that any access patterns, like we should define our key range partitioning in such a way that there are no hotspot being created. Let's say you have timestamp data. Okay, you have timestamp data, and it could be possible that let's say today, मतलब आज के दिन there is too much write data, ठीक है, there is too much data generated on the live streams and I am consuming those live stream, and there is too much data today. इंडिया पाकिस्तान का मैच चल रहा है, बहुत ज़्यादा डेटा आ रहा है, ठीक है. तो we have to ensure that if we are doing partitioning basis timestamp or like any such fields which can cause such issues, we have to ensure that we are not creating those hotspot, so that our system is not overloaded. Like if you look at the overall TPS, it's manageable, but the single partition is hit too much, so it can increase latency and it can also bring your that single partition down. So we should avoid that. So let's say in case of partition timestamp specifically, what you can do, you can attach some kind of prefix to timestamp to solve this issue, ठीक है. जैसे हम S3 में करते हैं, like when you store data to S3, we try, if we are storing data for timestamps, we try to store data. These are two examples. Which is better? ठीक है. So here if you see, for all the queries, the partition will start from 202022 for lot of queries. But if you do this way, ठीक है, the prefix will change every time. So this is better approach. अगर आपने S3 पे थोड़ा बहुत काम किया, लाइक इफ यू हैव स्टोर्ड मल्टीपल फाइल्स ऑन एनी काइंड ऑफ ऑब्जेक्ट स्टोरेज, देन यू माइट हैव डिड दिस, यू माइट हैव डन दिस अर्लियर, ठीक है. सो सिमिलर केस हियर, वी आर ट्राइंग टू अवॉइड व्हेन वी ट्राई टू रीड द डेटा, वी ट्राई टू अवॉइड दैट काइंड ऑफ थिंग. सो यू कैन अटैच सम काइंड ऑफ प्रीफिक्स, ठीक है, और एनी सॉल्यूशन दैट वर्क्स फॉर यू. बेसिकली व्हाट वी आर ट्राइंग टू डू इज वी हैव टू अवॉइड hotspots here. The partition which we are created, which we have created, we have to avoid the hotspots. Second approach is partitioning by hash of key. So in first approach, what we did was we tried to partition the databases, the keys, like you define the key range for the keys, and that particular range will reside on that particular partition. A to E वाला first partition में, F to P वाला second partition में, then Q to Z वाला third partition में. Similarly, what if we create hash of those keys? ठीक है, instead of keys, what we are trying to do is we are trying to create hash for the keys. This might help to solve your skew data in hotspot because you are creating your hash. For example, Cassandra and MongoDB use MD5. ठीक है, you can use any hashing algorithm here. It's not like you have some security and like security concern and you have to choose some मतलब ऐसे खतरनाक वाली hashing algorithm. It's fine if you use MD5. MD5 थोड़ा पुराना है, it's not recommended for security purpose as such, but for these kind of use case to store the data, actually you can use this. So Cassandra and MongoDB use MD5. What we do is we assign each partition with range of hashes. Let's say you have multiple partitions, you assign the range of hashes, and same thing you do what we did here. Once you assign the ranges, what you do, you will स्टोर द डेटा, ठीक है, बेसिस रेंज. जैसे इसका क्वेरी है तो इस पे डेटा, इसकी क्वेरी है तो इस पे डेटा, इसकी क्वेरी है तो इस पे डेटा. सो दैट वी आर ट्राइंग टू डू हियर. नाउ we have assigned a range of hashes to each partition. Now keys will be stored in partition whose hash falls in the specific range. समझ गए ना बात? जिस पार्टीशन में अपना मतलब जिस रेंज में अपना पार्टीशन फॉल कर रहा है, जैसे उसी रेंज की रेंज की अगर कोई वैल्यू राइट करनी है हमें, देन वी विल गो टू दैट पार्टीशन एंड देन गो राइट द डेटा. समझे बात? Now there could be one disadvantages of this. If we see the benefit of first approach, what was it? It was that we can do range queries very easily. ठीक है, but in here since we created hash of those keys, जैसे A to E था, अब इसका partition A B मतलब if we created the hash out of it, it will be A B C D to E F G H I. ठीक है. Now range query doing here will be a not that efficient as we did in case of first approach. फायदे हैं, नुकसान होंगे. So we have to go with whatever is suitable for our use case, right? Like whatever works for use case best, we have to go with that approach. Now moving to another topic where we'll be discussing about partitioning secondary indices. So one is primary index which you create on your database, then you also create multiple indexes. ठीक है, एक तो primary key पे आप data store कर रहे हो, that you have defined your partitioning basis keys which you are keeping. ठीक है, यहाँ पे hash पे we defined our partition basing the hash which is created out of key. But what if we are trying to create indexes? What if we are trying to create indexes which is not your primary key? ठीक है, जैसे in case of DynamoDB we create secondary indexes to fasten our queries. ठीक है, फॉर ए सिंगल DynamoDB टेबल यू कैन क्रिएट अप टू 20 GSIs. ठीक है, ग्लोबल GSIs. ठीक है, सो यू इफ लाइक अ सेम यूज केस विल गो देयर. तो once your database exceeds, or like once your data exceeds a particular limit, you will have to partition that data on secondary indices as well. ठीक है, ऐसा तो होगा नहीं कि secondary index में लिमिटेड डेटा आ रहा है. We will have that amount of data on secondary indexes as well. So how can you partition it? There are two ways basically. One is by document and second one is by term. So if we talk about the first approach, what we are trying to do is, let's say you have two partitions here, partition 1 and partition 2, and this is your primary key index where you are maintaining value and then some value. So let's say your key is 191 for which you have stored color red and make is Honda. Basically आप कार के colors and which companies has created it वो आप store कर रहे हो अपने database में with some specific keys. जैसे होंडा की कीज़ मान लो 191 है. ठीक है, सो सेम इन केस ऑफ पार्टीशन 1 वी हैव 205 विच हैज़ कलर ब्लैक एंड मेक फोर्ड. सिमिलरली वी हैव पार्टीशन 2. नाउ इफ यू आर ट्राइंग टू क्रिएट सेकेंडरी इंडेक्स फॉर कलर, ठीक ठीक है. Let's say I'm getting too many queries on color, that I want to see cars of red color, I want to see cars of green color, I want to see cars of black color. So since there are lot of read queries on the color basis, what we will do, since it's not the primary key, we will create a secondary index for that. ठीक है. सेकेंडरी इंडेक्स हमने बना दिया है, सो दैट इफ यू हैव इंडेक्स द डेटा वी कैन सर्व द क्वेरीज फास्टर. So if we created the index in case of by document, the secondary index will be created at partition level. ठीक है. So for case of red it will be 191, for case of black it's 205. In second partition for red it is 515, and for silver it is 603. ठीक है. So this is the way you created your secondary indexes. Now how you will retrieve the data. Each partition is completely segregated. Create local indexes. This we discussed. Read queries on secondaries could be expensive gathering data for. Now if we talk about read write, you have to gather data from multiple partitions. Let's say I got a query that I want to get all the cars for which color is red. Now I have to go all the partitions to query for the red color. समझे बात. I will go to this partition, then I will go to this partition and then see do I have any cars with red color. If there are, then gather this data and return to the query. ठीक है. Extract the data from the database, extract the data from the partition, gather this data. You have gathered the data and then return the query to user. ये अपना user. ठीक है. तो it's used in MongoDB, Cassandra, Elasticsearch. Second approach is by term. ठीक है. So instead of creating these local indexes, you will try to create global index. ठीक है. सारे partitions का combine करके single index. We will construct a global index which covers data in all partitions. ठीक है. So all the partitions which you have created, you will not construct an index basis that partition specific to that partition. No. ठीक है. वो नहीं कर रहे हम. यहाँ पे हम क्या कर रहे हैं, for all the partitions combined you are creating a single index. Global index is also partitions. We have to ensure that, because like since you are creating a single index for all the partitions, you will need partitioning of that index as well, because after a certain point of time you will not be able to store the data on that single node itself. You will have to create multiple partitions and then store the data for the global secondary index on those nodes. Like for partitioning we can use something similar to range partitioning, which we already discussed. Now there are some benefits. Benefit is the downside which we observed in first. What was it? It was related to read. If you are trying to read some data, you have to gather data from multiple local indexes, but in this case, since the data is present on single index, single global secondary index, the data can be fetched from single node and the read will be more efficient. ठीक है. मतलब ऐसा भी हो सकता है कि that for particular node there are multiple partitions, but you know where the data resides. You don't have to go to each and every index, each and every partition to gather the data for local indices. ठीक है. So you can hit only specific partition to gather data. Now how you can do it? समझे के बात. जैसे we mentioned that for partitioning as well, you can see you can use range partitioning. Now I'll know that in which partition. Let's say for global secondary index as well, you have 3 partition created, P1, P2, P3. Now let's say I want red cars. ठीक है. यहाँ पे A से B है, यहाँ पे C से R है, और यहाँ पे R के बाद क्या आता है अभी, S के Z. ठीक है. So I know the red color car will reside on P2, so I can directly go to this P2 and then retrieve the data. ठीक है. Read काफ़ी efficient हो गई अपनी. So read is one benefit. Now there can be some downsides as well. ठीक है. So in case of downsides, the writes will be heavy, because we are trying to write trying to write a single document, and which can affect multiple partitions. Terms and located on different partitions. ठीक है. It can be located on different partitions, so writes will be heavy as compared to read. Read will be simpler, because you know that which specific partition you have to hit. It can be used in DynamoDB. ठीक है. DynamoDB में ये feature है which you can explore and use. In case of DynamoDB, you have both these features, local indices as well as global indices, so you can use any of those. Now once you have partitioned the data, there can be some scenarios where you have to rebalance the partition. ठीक है. Like earlier you created the partitions, when you moved you broke the data into multiple parts. Now there might be some scenarios where you have to rebalance this. You might have to rebalance those partitions which you already created. Let's say there could be some reasons, right? Let's say you have to add more CPU to handle more load, add more disk, replace a machine. ठीक है, एक तो ये हो गया कि आप नई एड, लेट्स से दिस इज योर क्लस्टर, ठीक है, दीज आर योर पार्टीशन. नाउ इट कुड बी पॉसिबल दैट यू आर एडिंग ए न्यू नोड, ठीक है. You there might be a possibility that you are adding a new node, there might be a possible that it is went down and then you replace it with new node, ठीक है. There might be possibility that you add more disk space, ठीक है. On this particular node itself you are increasing, जैसे disk कितना था आपने इसका disk कितना कर दिया, ठीक है. So these are the certain scenarios where you will have to rebalance the partition, the data which you actually the data which you already stored, you will have to rebalance that so that data is again evenly distributed, because that's our main goal, that we want to avoid any hotspots, ठीक है, avoid any hotspot, and data is always balanced in between the partitions so that your reads and writes are not affected that much. Balance चलता रहे, load impact ना हो, system अपना available रहे, so that's what we are trying to do, ठीक है. So in all these scenarios you will require movement of data from one node to another. Now what are the multiple strategies, what are the strategies which you can explore? First one is hash mode n, ठीक है. So what we are trying to do here is, it's not effective approach first of all, but what we are trying to do specifically here is, let's say you have three partitions, p1, p2, p3. This is p1, this is p2, this is p3. So in this case, let's say you have total 3 nodes, ठीक है. Let's say you have total 3 nodes. If I want to specify that where my where my writes will go, then you can take node, क्या कर सकते हो, इसका मोड ले सकते हो, ठीक है. सो दैट आई नो दैट विच पार्टीशन आई हैव टू गो टू. बट इन दिस केस व्हाट इफ आई एड ए नोड, ठीक है. इन दिस केस दिस n विल चेंज, it will become 4. Let's say I remove one node, ठीक है. Let's say I remove 2 nodes, then your n will become 2. So your function will keep on changing, and in this case you will not be let's say when you store the data, you store the data which n equal to 4, ठीक है. But when you are trying to read the data, now n is 2, ठीक है. So you will hit the node 4 in this case, but the data is actually present on second node. So this is the scenarios which it can create, because n can change, and changing node number where data will be stored, ठीक है. So you will not have a perfect place or perfect algorithm to store the data, which can create issues. So it's not effective and it's used nowhere, I guess. Like I haven't found any examples where it is being used. It's a simple approach, but can't be used if your nodes are added or nodes are replaced. So there is some big issue associated with it. Now there are some other techniques which are used in multiple data meshes basis their use case. First one is fixed number of partitions. So you create fixed number of partition, ठीक है. It's basically used in RAG, Elasticsearch, 𝐂𝐤, Voltemort. So what you are doing, you have created lot of partitions, ठीक है. So जैसे एक आपका ये नोड था, ठीक है, नोड नहीं, एक आपका डेटाबेस क्लस्टर है, ठीक है. फॉर दैट डेटाबेस क्लस्टर यू मेंशन दैट आई विल हैव 1000 partitions, ठीक है. नाउ एज एंड व्हेन न्यू नोड अराइव्स, you will divide these partitions into those nodes. Let's say you have 10 nodes earlier, ठीक है. So what you will do, you will break these 100 partitions into 10 nodes. So let's say for each node you are assigning 100 partitions to each node. Let's say my node increases to 12, so we will assign those partitions again to evenly distribute the data by 1000 by 12, ठीक है. So you have created fixed number of partitions, and as and when your nodes increase or decrease, that partitions are rebalanced among those nodes. You have specified the number of partitions earlier only. So when let's say you are adding new nodes, so few partitions are assigned to a node to make distribution even. So in this case not all partitions will move. Let's say this was your earlier structure, that you have in this case 16 partitions and you have 4 nodes. So earlier what you did, you assigned 4 partitions to each of the nodes. So p1 to p4 goes to node 1, p5 to p8 node 2, then p9 to p12 node 3, so on and so forth. Now let's say I'm adding a new node 5. In this case you will pick some partitions from here. Let's say you picked some partitions p3 and p4 and then p5 from here, okay, and you moved the data from here to node 5, okay. So number of partitions will always be fixed here, as number of, like, the nodes can change, they can decrease or they can increase, but द पार्टीशंस विल बी फिक्स्ड, ओनली द असाइनमेंट विल चेंज, ठीक है। जैसे P3 P4 पहले नोड 1 के पास था, नाउ इट इज़ असाइन टू नोड 5, समझे बात। सो पार्टीशन साइज शुड बी नॉट टू स्मॉल एंड नॉट टू लार्ज, दिस वी हैव टू एंश्योर दैट like in case of elastic search, if you have used in past, we always do that basic analysis when we define our structure for elastic search कि मेरा shard का size ये होगा, ठीक है, partitions basically, ठीक है। तो we have to do that analysis beforehand so that in future we can avoid any scenarios that we are trying to change the partition size, because that can cause issues and it can also lead to downtime, ठीक है। वैसे इलास्टिक सर्च में ब्लू ग्रीन डिप्लॉयमेंट होता है, बट वी ट्राई टू come up with the exact analysis, not exact, but try to come up with some kind of analysis so that we can define the size of the partitions beforehand. So it should be not too small, so, because if मतलब बहुत सारे partition बना दिए, 1,00,000 बना दिए, so there will be lot of management overhead, ठीक है। You have to basically manage those partitions. Let's say a new node is added, so there will be lot of partitions which you have to manage to assign to that node, and if a node is removed, then you will have lot of partitions with no node assigned, so you will have to assign those partitions back to some nodes. So there will be lot of management overhead if you are creating too small partitions. What if you create partitions too large, कि मैनेजमेंट ओवर नहीं लाना, मैनेजमेंट ओवरहेड नहीं लेके आना है, पार्टीशन बहुत बड़े बड़े बना दो, ठीक है। कि मेरे पास सिर्फ 10 पार्टीशन है, एक नोड का एक पार्टीशन, ठीक है। So rebalancing on nodes failure, when there is a node failure, if you are trying to rebalance it, it will be very expensive because you have to move huge chunk of data, समझे बात। एक काम को एक साथ करो और एक काम को ब्रेक करके करो, कौन सा आसान है, समझे बात। जैसे एक महीने में आपको जिम जाना है, तो एक दिन में आप 24 घंटे कर लो, या फिर आप रोज़ 1-1 घंटे करो, ठीक है। तो देर इज़ अ डिफरेंस, and second one is easier and more beneficial. So we have to ensure your partitions are not too small and not too large. It's important that you come up with this number with proper analysis, and इनिशियली व्हेन यू क्रिएट योर इंफ्रास्ट्रक्चर, ठीक है। जैसे मेरे को इलास्टिक सर्च क्रिएट करना है, आई टू सर्व माई एनी ऑफ माई यूज केस, सो यू शुड डू सम काइंड ऑफ एनालिसिस टू एंश्योर दैट वट एवर पार्टीशन साइजिंग यू आर डिसाइडिंग, कि मेरे पास इतने रेप्लिका होंगे, इस पार्टीशन की साइज होगी, ऑल दोज थिंग्स, ऑल दोज पैरामीटर्स विद इन द कॉन्फिग फॉर इलास्टिक सर्च सेटअप यू शुड कम अप विथ आफ्टर प्रॉपर एनालिसिस. Another approach is dynamic partitioning, ठीक है। I don't want to fix the number of partitions कि मेरे पास इतने partition होंगी. Let's say I want to create the partition should be created dynamically. It is used in HBase. So key range partition database create partitions dynamically. When we say dynamically, as partitions grows and exceeds certain limit, it is split into two parts. On data deletion, it is required that partitions can be merged. So let's say this were your partitions, ठीक है। Now ठीक है, सो लेट्स टेक सिंपल एग्जांपल कि दिस वन वाज योर नोड, ठीक है। सो यू इनिशियली यू क्रिएटेड P1 एंड इट वाज असाइन्ड टू नोड 1, ठीक है। नाउ लेट्स से माय पार्टीशन साइज वो डिफाइंड वाज 10 GB. इफ the partition size exceed a certain limit, I will break this. So let's say the partition size of P1 is right now greater than 10 GB, it's 11 GB now. So what you will do, you will create two partitions now, ठीक है। P1 is 10 GB, कितना होगा 11 का आधा, 5.5. Let's say you created one partition of 5 GB and then you created P2 of 6 GB, ठीक है। Now if data again grows on some partition, let's say this P2 again exceeded with more than 10 GB, let's say it's 12 GB, then again it's 6 GB, and then your P3 will be 6 GB. बात समझ रहे हो। एंड इफ देर इज लॉट ऑफ डेटा डिलीशन, ठीक है, सम कुछ डेटा डिलीशन होगा तो फर्क नहीं पड़ेगा। इफ देर इज लॉट ऑफ डेटा डिलीशन कि एक पार्टीशन पहले 10 GB का था, ठीक है। लेट्स से यू हैव टू पार्टीशंस ऑफ 10 GB ईच एंड देर इज लॉट ऑफ डेटा डिलीटेड ऑन दोम। लेट्स से इसमें अभी 4 GB का डेटा बच गया, इसमें 4 GB का डेटा बच गया, तो एसबीएस विल कंबाइन दिस पार्टीशंस टू क्रिएट ए सिंगल पार्टीशन ऑफ 8 GB, ठीक है। तो इफ व्हेन वी से डायनेमिकली बोथ ऑफ द सिनेरियोज कैन एक्सिस्ट, आइदर यू कैन ब्रेक दोज पार्टीशंस और यू कैन मर्ज दोज पार्टीशंस. अनदर अप्रोच विल बी पार्टीशनिंग प्रोपोर्शनली टू नोड्स, ठीक है। जितने भी आपके नोड्स है उस हिसाब से आप पार्टीशंस बनाओगे. सो इन केस ऑफ थर्ड अप्रोच, दिस डायनेमिक पार्टीशन, योर नंबर ऑफ पार्टीशंस वर प्रोपोर्शनल टू साइज ऑफ डेटा डेटा सेट, ठीक है. एज साइज इंक्रीजेज, एज साइज डिक्रीजेज, यू विल डिसाइड कि पार्टीशंस को मर्ज करना है या फिर पार्टीशंस को ब्रेक करना है. इन केस ऑफ सेकेंड अप्रोच, where we were creating fixed number of partitions, the size of partitions were proportional to size of data set. समझे बात? Size of partition will be proportional to size of data set. In case of Cassandra, there is another approach which is being used, which is number of partitions are proportional to number of nodes. ठीक है. So for a particular node you will specify कि हर node के मेरे 5 partition हो गए. So let's say I have created 10 nodes in my cluster, and for each node you have 5 partitions. So in this case you will have 50 partitions. Let's say my new node comes, then you will have 55 partitions. If new node again comes, then you will have 60 partitions. ठीक है. And whenever new partitions are created, data will be rebalanced among those nodes. So let's say we are adding a new node. So in this case partitions become smaller and data is moved. नया node बनाया, let's say in that example only that we have 50 partitions now with 10 nodes. A new node came, then we have 55 partitions. Your partition size will become smaller because some data will be moved to extra 5 partitions. Okay, so your partition size will become smaller, and those data will be moved to those partitions and it will be assigned to new node, 11th node. Okay, after split, take ownership of half of them and leave other half to place. So once the data is splitted, ownership of half is given to the new node, and half or the other half will be kept intact. Now let's move to request routing. ठीक है, एक बार हमने डेटा पार्टीशन कर दिया, like you have partitioned the data, you have to actually retrieve the data as well. ठीक है, कि मैंने डेटा स्टोर कर दिया, मेरे को ये बताओ कि मैं है क्या डेटा में. ऐसा तो है नहीं कि हमने पार्टीशन करके रख दिया, अभी उसका कुछ यूज़ नहीं है. सो बेसिकली वी हैव टू कम विद सम एल्गोरिथम और कम विद सम अप्रोच दैट वी कैन एफिशिएंटली रिट्रीव द डेटा फ्रॉम द पार्टीशंस ऑफ दैट पर्टिकुलर डेटाबेस क्लस्टर. ठीक है, सो व्हाट आर दोज? What is request routing? First, how will you solve read queries as rebalancing happens and data moves from one node to another? ठीक है, तो ऐसा नहीं होगा कि like we also discussed this when in the start of the video that data will keep on moving in those partitions. ठीक है, so when you are trying to solve those queries, you are not sure that on which partition the data will reside, because eventually the data can move between the partitions. ठीक है, so it's not like कि the time the data was stored on P1, so it will also present in P1 always. नहीं, it might have moved to P2, it might be possible that it is present in P1 only, but there is a chances that it can be moved to other partitions as well. समझे बात? So how will you do it? There is a lot of techniques which you can use. First one is like you route the request to any node via round robin. ठीक है, so let's say you went to P1 first. ठीक है, you didn't find the data here, you move to P2, like you in a round robin fashion. ठीक है, you are hitting the nodes one by one, and let's say if data is not found on P2, it will forward to some another partition. ठीक है, so in this case you will try to move to one to another and try to gather the data. ठीक है, eventually हमें मिल ही जाएगा. Another approach could be you install a routing tier in between. It will determine which node should request be routed. ठीक है, this is your client, and your routing tier will hold the logic. Routing tier will hold the logic that which particular partition of this DB cluster my request should be routed to. ठीक है, so routing tier will have the intelligence inbuilt that it will know that for a specific query, let's say I want to retrieve data for k equal to 3. Now this routing layer creates maintains some kind of mapping so that it knows that for k equal to 3 I have to hit this partition. So if you compare your second approach with first one is like very less efficient. In worst case you will have to hit all the partitions. ON approach, ठीक है, बहुत ज़्यादा टाइम लगने वाला है. Not use. क्यों करना है यूज़ अगर इतना टाइम लग रहा है तो? ठीक है, सो राउटिंग टियर इज मेंटेनिंग दैट इंटेलिजेंस इन इटसेल्फ दैट व्हेनेवर डेटा मूव्स इट विल maintain that logic, and it will know, this routing tier will know that which specific partition I have to hit to retrieve the data. Another approach could be that clients are aware of the partitioning scheme. ठीक है, clients are aware of the partitioning and how the partitions are assigned to those nodes. ठीक है, तो यहाँ पे routing tier जो था we removed this entirely. ठीक है, the routing tier जो था we removed this entirely, and clients are already aware that which particular partition or which particular node I have to hit to get the data from. So you don't need any logic in between, any routing tier logic in between. Now, how will you know that assignment of partitions to nodes? So there can be multiple ways. There can be multiple ways that I know this particular partition is assigned to this node, and then it is reassigned to this node, and then it is reassigned to this node. So you can use certain mechanisms. First one is using of a coordination service such as 𝐤𝐤keeper. ठीक है, 𝐤𝐤keeper basically helps to keep track of all the partitions. ठीक है, it keeps mapping of partitions to node. So 𝐤𝐤keeper basically is your coordination service, is used in a lot of places. ठीक है, कि मेरे को लेट्स से हेल्थ स्टेटस मेंटेन करना है, तो 𝐤𝐤keeper कैन मेंटेन हेल्थ स्टेटस बिटवीन द नोड्स की इफ एवरीवन इज अवेलेबल और नॉट. सो 𝐤𝐤keeper कोऑर्डिनेशन जो भी करना है, मतलब यू हैव लॉट ऑफ नोड्स इन योर क्लस्टर एंड फॉर एनी काइंड ऑफ कोऑर्डिनेशन you can use 𝐤𝐤keeper. It is being used in HBase and Kafka. Another could be use gossip protocol. Okay, so if we talk about gossip protocol, we haven't created any videos as such as of now in your playlist, but gossip protocol का basic idea ये है. Let's say this is your cluster. ठीक है, so when we say gossip protocol, वो बातचीत करते हैं आपस में. ठीक है, so these nodes will interact with each other. ठीक है, each and every node will interact each other. ठीक है, so via this gossip protocol they will know that which partition is specifically assigned to which node. It is being used in Cassandra. Another approach could be that you create your own routing tier. You create your own routing tier which don't require any such things like 𝐤𝐤keeper or like gossip protocol. You maintain on your own all your logic by your own. You are not using any library, you are not using anything. You are creating your own routing tier which maintains all this logic between the nodes, that which particular partition is assigned to which specific node. It is used in Couchbase, which use routing tier called 𝐬𝐤𝐻. So this is all about partitioning and what are different techniques of partitioning. I hope you learned something new today. We will be creating more such contents, discussing all those chapters in coming days. Till then, stay safe. Tata. Bye bye.